Hello, everyone. Thank you for joining for our advanced weather spot class for the Inland Northwest. Just wanted to confirm that you can hear me. I'm assuming you can. Thank you. Thank you, Carl and Heather. Well, let's get started. So yeah, thank you for joining. My name is Valerie. I am a lead meteorologist here in NWS Spokane, and I will be talking for about the next hour and a half for this advanced weather spotting class. So what we're going to focus on for today, we are going to, since this is an advanced weather spotting class, I'm just going to assume that you've attended one of our courses before, but we're just going to kind of re-understand the roles and the importance of the weather spotter, describing the severe weather threats that we experience here in the inland Northwest. Going to talk about how you can provide accurate and timely reports of severe weather, how to properly define a severe weather storm and basic thunderstorm structure, identifying clouds and features of thunderstorms, and some safety tips on how to be safe during severe weather. So first we're going to discuss some of the things that have happened over the last couple of months. So just back in February, we had some significant flooding over the Palouse and up into the Spokane areas where a lot of the flooding was focused. These are pictures from February 23rd and February 24th, but the flooding started on the 23rd from Palouse, Washington, where there was a lot of snow, lowland snowpack, especially over the Palouse, where they had several inches of snow. And then we had a very warm and heavy rain event come in, and that resulted in rapid lowland snowmelt and some significant flooding on some of our smaller rivers, but even over the Palouse River. This is in Palouse, Washington, where a lot of the downtown businesses and homes, there was some flooding in it, as this is a picture from flooding in a basement. And then we saw some communities as well, like the park, that was completely inundated with water. Going back a little bit further, in September, we had some significant dust storm over in the Palouse again. The Palouse is our weather winner for this next couple slides, where we had a haboob from some thunderstorm outflow loft up a lot of dust over Pullman and most of the Palouse. That you can see, this is a pretty good classic haboob picture, and resulted in very low visibility from dust and from pretty high winds. And on the same day, Orville, Washington saw some wind damage from thunderstorms and saw less dust, but more tree damage. You can see here some pictures of some snapped trees. So this, I was corrected, and this is some people are attending a spotter talk for their first time this evening. So thank you for joining us. Thank you for new, and we always are welcoming for our new people and are also returning people, because can't never have enough weather. But just kind of talking about an overarching view of the National Weather Service. So we are an agency of the federal government, and we are under the Department of Commerce is our main agency, but then we are a line office of NOAA, which means the National Oceanic and Atmospheric Administration. We are called a weather forecast office within the National Weather Service, and we are one of 122 offices nationwide. So we issue forecasts, watches, warnings, and advisories 24/7, 365. We are always here. We have about 20 staff members at our office, with 2 to 3 people per shift. So if you give us a call, we will be here. Someone will answer the phone. And no matter where you go in the country, there is a weather service office that serves that local area. Our mission is to, how many in Washington State? There's 2 in Washington State. There's 1 in Seattle and 1 in Spokane here. But so Seattle serves Northwest Washington. We serve Northeast Washington and North Idaho. And Portland serves Southwest Washington, parts of Southwest Washington, and Pendleton also serves a small part of like South Central Washington. And so here's our view on a map with Spokane circled. So you can see that in the inland Northwest, we have Spokane for most of northeastern Washington, most of eastern Washington, and most of the Idaho Panhandle. To our west, we have Seattle that serves much of Northwest Washington, Portland, just some parts of Southwest Washington, and Pendleton, parts of South Central, Southeast, South Central Washington as well. And then Missoula also serves some of the Idaho Panhandle as well. And then some centers that the National Weather Service also has is we have the National Weather Service, we have the Storm Prediction Center, which I will be talking more about throughout this presentation. That is located in Norman, Oklahoma, and they are the severe weather, severe thunderstorm center where they issue risk outlooks for thunderstorms, and they are the ones who issue severe thunderstorm watches and tornado watches during severe weather days. And then we also have the National Water Center, and within that, the river forecast centers. There's river forecast centers as well all across the country. And the one that we have is the Northwest River Forecast Center, which is located in Portland, Oregon. It's actually co-located with the Weather Forecast Office there in Portland. And then we have the Weather Prediction Center, which they forecast precipitation and snow, and they do the surface analysis, and they also issue the extreme rainfall outlook as well. So they are a national center located in College Park, Maryland. So there are many ways that we see the weather. We are just an office located in Spokane, but we serve much of eastern Washington and North Idaho, and we can't physically see with our eyes most of everything and every weather that is occurring across our region. So that's why we also train our spotters, so you can help be our eyes. But outside of what we can personally see outside our office and outside of our spotters, we utilize Doppler weather radar, and that's how we see precipitation and hail, and also that's how tornadoes are seen as well. And we will discuss some aspects of Doppler weather radar a bit later on in the presentation, but that's one aspect. We have radiosonde or weather balloons, where we launch weather balloons twice a day to get a view of the profile of the atmosphere from the surface all the way up to 100,000 feet. And this is what it outputs. So the red line is temperature and the green line is humidity from the surface all the way up until the balloon pops. And we can utilize that to really get a good look of what's going on in the atmosphere and really understand the state and how the current observations will impact the weather that day. We also utilize satellite a lot. This is a picture of the GOES satellite, GOES 18 or GOES West, of the geocolor composite. And this is on a clear weather day where all of the white is snow on the mountains, but we use that to see from above, and we can see the clouds. We could also see dust on satellite. We can see new fires that start on satellite. And so there are a lot of good capabilities that we can use satellite for. We also have, not us personally, but we are dialed into the webcams that are located all around our forecast area. We utilize a lot of webcams from the DOT. This is just an example, and especially for kind of getting the eyes for snow, we'll use webcams for dust, especially in the Columbia Basin and on the Palouse, and just knowing if it's raining, just utilize anything that we can with our webcams as well. And then weather stations. We maintain several weather stations across Eastern Washington, North Idaho, located at some airports, but we also look at automated weather stations that are done by fire agencies and also the DOT as well, and the WSU AgNet, and also local citizen weather stations as well. If you have a automated weather station that reports at your house, you can connect it to our webpage so we can have access to it and see. So weather hazards change with the seasons. For the summer, we are really focused on fire weather and thunderstorms, but that fire weather has to do with wild wind and dryness, but also lightning and smoke. Thunderstorms, hail, wind, rain, and lightning. And then flooding, river flooding, that is usually some of our, one of our like winter into early spring hazards from river flooding, but also flash flooding from the summertime, in the late spring and summer, when we get more of our thunderstorms and our slow moving thunderstorms that move over urban areas and also over fire burn scars. And then winter storms, which we all know and love out here in Eastern Washington, well, at least I do, in North Idaho, where we won't be focusing on winter storms a lot, but we will be talking about, but those come with snow, ice, rain, and wind. So terrain makes all the difference. For residents of the inland Northwest, we know that it's pretty dry out here, especially compared to Western Washington, where they see a lot more precipitation than we do in any given year. And that's because we have this huge mountain range in central Washington, the Cascades, that kind of act as a big barrier for weather systems. So as weather systems move off from the Pacific into Western Washington, as it encounters the mountains, the air lifts over the mountains and kind of precipitates out, and that's why we can see this maximum over kind of on the westward side of the Cascades. Then as the precipitation tries to move east of the Cascades, and then the wind kind of goes over into the eastern side of the mountains, the storms dry out, the rain dries out, and the wind, it warms up. So that's why we see this pretty stark difference, especially in kind of near the Wenatchee area and also Douglas and Grant County in our forecast area that just doesn't see a lot of precipitation. And that's what we call a rain shadow effect. If you read our forecast discussions, we will mention rain shower, precipitation shadow a lot, because a lot of the storms, if they're moving from direct west to east, they'll looks like it skips over central Washington, and then the precipitation will pick back up as it goes into further eastern Washington and North Idaho. So what's in the spotter report? Well, we want to know the specifics. We want you to tell us a story, who you are. If this is your first time attending a spotter training, you will get a spotter ID, and we use that to plot it on a map. When you register after this training is done, you will be reached out to by Robin Fox, who is our spotter coordinator right now, and she will have you fill out a form that lists your name, how you want to be contacted, your phone number, and your address and your elevation. And that gets put into our system. And if we just enter your spotter ID, we can get all that information to accurately report what you are seeing. So what you were reporting, we want to know the speed or the damage of the winds, the size of the hail, how much rain did you get, what type of flooding you're seeing, poor visibility from either from dense fog or even from dust, and just for the winter, like if you're seeing freezing rain or sleet or how much snow you got. We want to know the specifics. When did it occur? Where did it occur if you're not at your location? And just estimates of wind speeds and hail size to be as accurately as possible, and also damage and any injuries if you are aware of it. If you're unsure, such as if you don't have a exact measurement of hail or exact measurement of snow or even the wind speed as well, report your uncertainty. Feel free to include your reports when traveling, because if you just give us a specific location, we can also plot that on your map, and any delayed or secondhand reports. We do care about smoke visibility too, and that's just not as common. So, but yeah, any visibility from dense smoke, fog, dust would be good to report in your reports. So this is going to be a bit interactive. So I'm gonna launch our first poll question. 1 second. Okay, so what types of severe or hazardous weather do we not experience in the inland Northwest? It's okay, it's not graded. Okay, I'll give 5 more seconds. Okay. 95% of you said hurricanes, and that is the correct answer. So how do you report to us? You can give us a phone call. You will get all this information in an email, so don't feel like you have to take a screenshot of it. You will get a recap of everything. But you can give us a phone call. You can send us an email. You can report online at inws.nsip.noaa.gov/report. And this picture to the right of it is what you would see on that website, and you could select your report type. The only issue with that is that you would have to write your spotter ID in the comments of that, and but it's still good. It still is utilized, but we would just have to take the extra step to input it. But that's a good way to input it as well. And then also social media. We are on X and Facebook at NWS Spokane. So another way, if you don't want to utilize any of those, there is another way to submit reports, and that is by downloading an app called MPING, which stands for Meteorological Phenomena Identification Near the Ground. This is an anonymous app. Yes, we do look at CoCoRa's data. If you are a CoCoRa spotter, CoCoRa's reporter, we volunteer, we get those automatically ingested into our system as well. And so if you send your reports into CoCoRa's, you do not, for precipitation specifically, you do not need to call those reports into us because we automatically get them. But if you are a CoCoRa's observer and you already, so you're in our system, so you can also give us a call, do the same things for any other types of weather hazards. And so there is a free app, and this is anonymous, so we won't know your spotter ID or anything with it. It has a little more, it's not as freestyle because you have to click what you're saying, and there's no way to enter comments or anything. But this is a good way to like on the spot report types of what you're seeing. I really like to use MPing, especially for precipitation type. But you can also, yeah, you can report hail, wind, flood, anything that you want. And that is located on the app stores, but it's also sent directly to us. So emails are important. Besides your phone number, it's important to give us your email address, because if we are expecting a widespread severe weather outbreak, we might email you beforehand and kind of put that alert out just so you are aware that we will like for people to send in observations and reports, kind of just alerting the network. We don't do this often. I've been here for 5 years, and I'm not sure if we have done that in the last several years, but if we are expecting something, that could be something that we do. We also do send periodic emails with the quarterly newsletter and upcoming training opportunities. And we may contact you as a registered spotter. It's like I said, emails are important, but we also will have your phone number, and then that your location is ingested into our system. And if we see a strong thunderstorm or something move over your location, we may give you a call to get ground truth, especially if we haven't had any reports yet. And we use spotter reports to help verify the warnings that we put out. So it is important that if you do see something, to give us a call or give us an email whenever you can, because we utilize our spotters heavily during severe weather season to verify what we're putting out. So here's our next question. Is it important for weather spotters to keep their email and phone number current with the NWS? I'm gonna close that. That was an easy one. Yes, it is important. If you do move or you get a new number or a new email, just give us a call or an email and let us know so we can keep our phone, our information, or your information up to date. Because we have had in the past where we've called numbers and that's not in use anymore or anything, and we want to utilize you. So for thunderstorms across the United States, we are kind of, you can see the West Coast is a big minimum of thunderstorm activity across the country. And that's just because of the Pacific Ocean. The ocean is so cold that it generally keeps us more stable in the atmosphere compared to the rest of the country. But for 2023, this wasn't updated for 2024, but Spokane had 19 days, Lewiston had 18 days, Wenatchee had 14 days, which is kind of on par with the color coding for the annual mean thunderstorm, which most of the inland Northwest is in 9 to 18 days per year, except for far Northeast Washington and North Idaho, which is in 18 to 27 days. So what creates a thunderstorm? So the first ingredient that we need for a thunderstorm is moisture, and that can be measured by the dew point, or it could also be measured by precipitable water. They're correlated. Higher dew points generally correspond to higher precipitable water values as well. But in the eastern Washington, North Idaho, we're a pretty dry area with, I think, let's see, with dew points for today. Right now, the dew point in Spokane is 18 degrees with 17% relative humidity. And so we're quite dry here, and less than 55 degrees is generally pretty dry. But then for the inland Northwest, when we start getting in dew points in the 50s or the mid to upper 50s or even to the low 60s, that's when we start seeing good moisture values for our area to see thunderstorms. Usually when we see our humidities that high, there's probably a chance for thunderstorms that day. Not always, but it's definitely a good indicator. And then we need a lifting mechanism, and that could be in the form of a cold front. It could be in the form of an upper level trough, which is a term that we like to mention in our forecast discussions, which is also like a low pressure system. Or even the mountains, as I mentioned earlier, the mountains can also act as a lifting mechanism once air is forced, because if there's air coming, especially in kind of a mountain range, it's hard. It can't really go around the mountain, so can only go one way, and it goes up, and that forces air to rise and creates clouds on the windward side of the mountain. And then once you get on the leeward side of the mountain, that area dries out, and you usually see drier conditions and less clouds and more sunny skies. And then third ingredient is instability. So instability is just a way for clouds to rise, and for precipitation and air parcels and clouds to rise. We will go more into the specific ingredients over the next couple slides, but this is a very important ingredient, because if you have a stable air mass, clouds can't rise, and you can't really get the upward motion and the cooler temperatures and just the energy and momentum you need to create thunderstorms. But in an unstable environment, you can really see a lot of that vertical motion with clouds getting really tall and allowing thunderstorms to form. Those are the three main ingredients. But then the fourth ingredient to get strong thunderstorms is wind shear. So wind shear is the speed or directional change of wind from in different levels. So on the left image, that is kind of a schematic of little to no wind shear, where the winds pretty much are the same from the ground up to the top of the cloud. And that kind of just allows the cloud to stay vertically stacked. And that's when we see more like short duration thunderstorms, like quick pulse up and down thunderstorms that don't last very long, because the downward motion from the precipitation falling usually can overpower the upward motion needed for the thunderstorm to sustain itself. So it just collapses pretty quickly. But then when you get wind shear, especially, can either be directional wind shear or speed wind shear. That's when you see some drastic differences in the wind speed or direction from the ground to up above the surface through the cloud tops. And that's when you start seeing thunderstorms to be a little more tilted in the atmosphere. And when you have more tilt to a strong thunderstorm, the updraft that's helped sustain the precipitation and the development of this thunderstorm, and the downdraft aren't on top of each other, and they're kind of they're opposite of each other and different levels of the clouds, so they're not really overpowering each other. So that's where you see in stronger thunderstorms, you'll have like rain-free cloud bases but then you'll have precipitation more towards the other edge of the cloud of the storm. So a little more knowledge about, more discussion about each specific ingredient. So moisture, as I mentioned, dew point, which is pretty much how much moisture can be held in the atmosphere. So a higher dew point will allow more moisture to be held in the air, and then lower dew points had just a less availability for moisture. So this helps forms the clouds and precipitation associated with thunderstorms. Our primary source of moisture is the Pacific Ocean, especially when we start to see atmospheric rivers or moisture plumes come in from the subtropical area of the Pacific Ocean. That's when we start to see more of those higher dew points and precipitable water values. But occasionally we can get some moisture from the Gulf of California or even Mexico during the monsoon season. And that's when we will typically see more elevated thunderstorms and when we are messaging dry thunder. So we monitor moisture. We can monitor moisture with satellite, like water vapor imagery and upper level soundings, and also our surface observations. So again, and it's another ingredient, kind of differed from that first slide that I showed, but is instability. Actually, oh yeah, and that's just how the atmosphere naturally mixes and how much buoyancy is in the atmosphere to allow a air parcel to rise above the surface. So in an unstable atmosphere, more moist air near the ground, it's warmer than the environment around it, so it can rise. And then in stable air, the parcel at the surface is the air at the surface is cooler than the air above it, so that warm air above it kind of acts as like a lid or cap, and it just keeps the air at the level that it's currently at because it can't go any higher. So we monitor this with upper level soundings and also surface observations. And also you can see it if you look outside and you start seeing, even if there's no precipitation occurring, if you start to see, even we call them fair weather cumulus clouds, if you see clouds building, that's typically a indication of an unstable atmosphere. Or even looking at smoke plumes. If you see a smoke plume rising kind of high, it indicates a more unstable atmosphere. But if you can see where the atmosphere is stable and where that cap is, even on smoke plumes, because you won't see it rising anymore. So instability, we can really message and understand how much instability is in the atmosphere by a term called convective available potential energy, or CAPE. And this is really just how much buoyancy and how much potential energy is in the atmosphere as clouds rise. So it's the amount of fuel available for developing thunderstorms, and also provides an approximation of updraft strength. So the higher the CAPE, the stronger thunderstorms can potentially be, and how tall they can get. So this is what CAPE looks like on an atmospheric sounding and high. So this is from Norman, Oklahoma. So these are values that we typically don't see in the inland Northwest because we are so dry, but we typically see values around in our stronger thunderstorm days, like up to 2,000, maybe 2,500, or even 3,000. And it's measured in joules per kilogram, so it is a unit of energy. So when we have high CAPE, that typically means storms will build vertically very quickly. And then the lifting mechanism, that's a process that forces air upward in the atmosphere. And that could either be mountains or terrain, air forced up the slope, or cold front, where cold fronts typically move into an environment that's warmer than it. So as that cold front comes through, it moves under the warm air and it forces that warm air to rise. But other sources of lift include warm fronts, heating from the Earth's surface, so just natural convection, outflow boundaries from just decaying thunderstorms, and also dry lines. We monitor this with satellite, upper radar, upper level soundings, and surface observations. And we can also, our weather models are pretty good at picking up on the different lifting mechanisms that are available, that are around. And so the terms that we could use with this is vertical velocity, vorticity, and front. The last ingredient that is needed for strong thunderstorms, like the last three ingredients that I mentioned, like if you have those three, you can get thunderstorms. And we could get those quick thunderstorms. You can get lightning, we can get small hail, and maybe breezier winds. But to get a true strong thunderstorm, you need wind shear. And as I mentioned earlier, this is just the change in wind speed or direction with height, which separates the updraft and the downdraft and allows these storms to continue and persist longer than if they were vertically stacked. It also enhances rotation within thunderstorms, and we can see wind shear by looking at our upper level soundings and our surface observation, and we monitor it with radar as well, because we can see on radar, since we scan different levels of the atmosphere, we can see if our thunderstorm is tilted and how long it might last. Yeah, once you get strong thunderstorms, you can see an anvil with it, and we will look at that in a second. So just for kind of remembering the thunderstorm basics for SLIM is you need lift, instability, and moisture. For just a normal classic thunderstorm, a weak thunderstorm, but to get stronger thunderstorms, you really need that wind shear component. So again, looking at thunderstorm basics. So I mentioned the terms updraft and downdraft a lot. And when you have that wind shear, you really have a separation of that updraft and downdraft, where in the area of downdraft, that is where you get most of the heavy precipitation and the downward motion, and where you see the high wind and hail threat, and also the leading edge of the thunderstorm that's kind of marked by a shelf cloud. And then the updraft is located on the backside of the storm, and this is if you have really, really strong updrafts, we'll have these rain-free cloud bases, where kind of the cumulus tower is located at the anvil, and you can really, the updraft motion, that can be really, really strong. So what is a severe thunderstorm? So when we talk about severe thunderstorms, like we talk about severe weather, really is talking about three aspects of a severe thunderstorm, and that's either by wind gusts of 58 miles per hour or greater, or some just noticeable wind damage, hail 1 inch or greater in diameter, and 1 inch corresponds to about the size of a quarter, or a tornado. Any tornado makes a thunderstorm a severe thunderstorm. Less than 10% of all thunderstorms are severe. And one common misconception is that the amount of lightning means a severe thunderstorm. Now lightning Ball lightning is very dangerous. It's always dangerous, even in weak thunderstorms. Even one thunderstorm that has one strike of lightning is very dangerous. The amount of lightning does not make a storm severe. It's really the wind gusts, the hail, or a tornado. Wind gusts 58 miles per hour, or hail 1 inch in diameter, or tornado. So there's a lot of ways to stay informed. And this is kind of a cute image that breaks down the difference between a watch and a warning. A watch, whether it's a winter storm watch or a high wind watch or a fire weather watch or severe thunderstorm watch, that's kind of looking more into the future, that we are seeing the ingredients in place for it to happen. And so that doesn't mean that that is currently occurring if there's a watch, but we are kind of giving a heads up and an outlook into the future that we are expecting that to happen. So if you are in a taco watch, you have all the ingredients. You have the shell, the lettuce, the spices, the filling for a taco, but you don't actually have a taco. You can't just, I guess someone could if they really wanted to, eat the individual ingredients of a taco, but you want a taco. But a taco, a warning, such as a severe thunderstorm warning, a winter storm warning, a high wind warning, a red flag warning, that means we are expecting that to happen now or in the very short future, short term. And so a taco warning, you have all the ingredients in place right now and you are about to shove it in your mouth. So that is just kind of a cute way to say the difference between a watch and a warning, because there is a lot of misconceptions, the difference between a watch and a warning. I've seen a lot of, like when we have a watch out, I've seen on social media, I've even seen in the news or just on Facebook or whatever, people saying, oh, we're in a warning right now when we are in a watch. They do mean different things, because a watch doesn't always necessarily mean a warning is going to happen. It's just kind of more of a heads up and hey, it's time to prepare, because it could turn into a warning, but it might not necessarily always turn into a warning. So as I mentioned before, the Storm Prediction Center in Norman, Oklahoma, they are the ones responsible for issuing convective outlooks, and they issue convective outlooks for the entire country. So they're looking, their main outlooks are days 1 through 3, but they do issue outlooks for through days 6 and 7 as well. And these are the different levels of their outlooks. We typically, in the inland Northwest, usually on a normal day when we are expecting thunderstorms, are just in this general thunderstorm outlook, where we aren't really expecting severe thunderstorms, but there is that threat for lightning and heavy rain and small hail. And a couple times a year, a couple times, we will usually be found, sometimes we'll be found in a marginal outlook. And that's when we are seeing those ingredients for severe thunderstorms. And we have the instability, the wind shear, the lifting mechanism, and the moisture. And the Storm Prediction Center will put us in a marginal outlook. And that generally means that an isolated severe thunderstorms are possible. Either they're limited in duration or the coverage and intensity isn't as widespread. And then for the slight outlook, that's when more scattered severe thunderstorms are possible. This doesn't happen every year. It's happened maybe a couple times since I've been here, but this is when there's a little more better chances for severe thunderstorms. Still kind of more short-lived and not as widespread, but there could be some intense storms. And as you get higher, it's just the severity or the coverage of the thunderstorms expands or increases. So enhanced has happened. I'm not sure. I don't think it's happened since I've been here in our area. I might be wrong, but I think it happened. There was an enhanced outlook right before, I think in 2020. And so that was pretty rare. And then also moderate and high, I don't think it's ever happened in our forecast area. You see these more east of the Rockies in central and southeastern United States for more like big tornado threats. So this is an example of just a convective outlook from the Storm Prediction Center. So this is an example from May 30th, 2020, when the Storm Prediction Center issued a slight risk for most of eastern Washington and central Oregon. And so it will highlight it by area, and we do coordinate with the Storm Prediction Center when they are putting out these outlooks, because we do have more of the local knowledge, because they're looking at it at a widespread scale, and we kind of have that local knowledge that we can help them just make these decisions on what type of outlooks to put out, because putting the inland Northwest or even anywhere in the Pacific Northwest in a slight risk, it's a pretty big deal. It doesn't happen often. If we remember back in March, I think the end of March, when Western Washington, Western Oregon were in a slight risk, and that was a pretty big deal, even though nothing actually happened for them. It was just more thunderstorms and just regular thunderstorms and lightning. The ingredients were there, and they just didn't line up all at once. And so I'd say if that same thing happened, at least in like the summer, it could have been much worse. So again, understanding the different terms between watch and a warning and then an advisory. Watch again is conditions are favorable in the next 24 to 48 hours in advance for a specific hazard to occur. And that's the time to have a plan of action and make your plan if something's going to happen. And then we have an advisory, which is kind of a synonym to warning, but the hazard is occurring. That it's just mostly an inconvenience to life and property. While we're not seeing significant threats to life and property, but kind of more of just like a heads up that this is occurring. So it's like using caution. You don't necessarily need to have a evacuation plan or like a life-saving plan in place, but just be aware. We do issue a lot of winter weather advisories in the winter for light snow events, especially over the Spokane area when it's around commute time. And even it's like we'll issue for 2 inches of snow, where it's like there's not going to be significant impacts if you're just at home from 2 inches of snow. But those who are driving or going on the highway, it could be an inconvenience if there is a backup or just slower driving conditions. But then a warning, that's also when a hazard is occurring and there's a threat to life and property, and it's advised to take protective action ahead of that specific hazard. Usually in the products that we issue, we do offer some tips on different actions to take. So on our website, you can go, our website is weather.gov/Spokane. And this is where you can find pretty much everything that we offer. Some important things, if you want to see what's occurring in the future for the weather, are the current hazards, radar data, our forecasts, and then river and lake forecasts as well. That's at the top of our screen. And at the bottom of our page, this is where you can see our area forecast discussion that we put out. We completely write new ones twice a day. And this is where we get more into the scientific and meteorology specifics of the weather for the next 7 days. This is where you'll find more of that meteorological jargon and talking more about the specifics of the atmosphere if you want to get really into the details of what's occurring. We have radar, you can get radar, satellite observations. This is also where you can find that submit a storm report link that I mentioned earlier. You don't have to memorize the link. You can also just get it from our website. And where you can also view storm reports that were issued over the last day or so. So for local severe weather climatology, by year, we typically see a lot more wind reports than hail or tornadoes. The last several years, our most active years have been 2012, 2014, and 1997. Again, like our most latest radars were installed in 1995. And then by month, since we're at the end of April, we are entering our tornado season. Most of our tornadoes in inland Northwest have occurred in May. And then our peak month for damaging winds and hail is July. But we do have seen reports November through January as well. But most of our severe thunderstorm reports do occur between May and August, which is when we have our warmest temperatures, more heating from the sun, and more moisture that could move up from the south and really move into that warmer air. By time of the day, well, our most active time is the mid-afternoon and mid-evening. This is because that's when the peak heating of the day, and you can have the most instability from the heat and the warmth of the day. But we still do get wind reports at night, but we're pretty less active in the morning. So our third question, what is an ingredient for thunderstorm development? Let's see. Okay, I'm going to close the poll. It's actually a pretty 50-50 split. Actually, the answer is high precipitable water. So high precipitable water is kind of synonymous to the high moisture, and that you just need a high moisture for a thunderstorm development. Positive lifted index was the answer that actually had the most votes. Lifted index is another way to measure the instability in the atmosphere it's an equation by looking at the difference in temperature between a parcel and the surrounding environment. But positive lifted index actually indicates a stable environment, where a negative lifted index indicates instability. See, someone has. Okay. So there's different types of thunderstorms. That could be a single cell, which, as I've mentioned, those are the cells that usually are pretty weak and short-lived, the ones that don't have as much as wind shear available, and they may produce severe weather, but not typically. A multi-cell thunderstorm are more organized, and they could last for hours, which all hazards are possible. And then a supercell, which is the strongest storm type, and these are generally long-lasting, and also all hazards are possible. For single cell thunderstorms, they typically last less than 30 minutes in duration, and that's because the weak wind shear that is in the environment keeps the storm vertically stacked. So the heavy rain in the downdraft will generally cut off the energy needing for it to persist, and so it just rains itself out and dissipates pretty quickly. These are most common in our summertime and more of like generally very short-lived pop-up thunderstorms where you can see it pop up and then it just disappears pretty quickly. You could get mostly non-severe wind gusts, small hail, and lightning. For multi-cell thunderstorms, these are longer in durations and the threats include strong winds, hail, heavy rain, flash flooding, and generally some weak tornadoes. They could be slow moving with flash flooding as a threat, and downburst, straight line winds, small to medium sized hail, and also lightning. And this is kind of a video of a multi-cell thunderstorm, and you can see that kind of just moves and then regenerates and dissipates and regenerates, dissipates and regenerates, kind of just pretty consistent over one area. And I'm sure that it saw probably a lot of, I don't know actually, but just seeing what's occurring, that flooding was probably a concern since there was a lot of rain just sitting over that area. And these are some different types of multi-cellular thunderstorms. You could have pretty disorganized one where there's just not much to them, but they are stronger, but there's not really much organization or structure with it. You could have squall lines or a QLCS. You'll kind of see those interchanged. A QLCS, which stands for quasi-linear convective system, or a squall line. And these are long lines of multicellular storms. You can see them because they really look like a line that's just going through, and they're typically associated with very strong cold front, and you could see really strong winds with these types of systems. And then you also see a faux echo where either a squall line or even just a regular just multicellular thunderstorm kind of surges out front that indicates strong winds and just a bowing appearance with it. And with these types of systems, you could see large hail, and we measure hail by the size and its diameter, but if you don't have a ruler available, you can always reference it to a common object at home. As I mentioned a little earlier, severe hail is classified as severe hail once it gets to 1 inch in diameter, or about the size of a quarter. And then as we get greater in size, like $50 for 1 1/4 inch, walnut for 1 1/2, golf ball for 1 3/4. And the biggest hail size that I've seen since I've lived here in Spokane, well, I didn't physically see it. It wasn't in my occurrence, but we did have baseball-sized hail that moved through like the Liberty Lake area back in 2022. This is a picture from Otis Orchards that was sent to us with egg-sized hail, but we did see egged baseball-sized hail with that storm. It is not recommended to use marbles as a reference for hail size because marbles come in a lot of different shapes, a lot of different sizes. So it's not very specific if someone says marble-sized hail, because it could really mean a bunch of different sizes. So we really encourage you to use these different objects, coins, or different types of balls, or an egg. For strong winds, as mentioned, we start to classify severe winds once wind gusts get to above 58 miles an hour, and that could be by if you have a wind sensor at your house or if you're just observing damage. once you start to see large branches broken or trees snapping in half, or kind of larger trees down, or even some structure damage, that's when you would start to see those stronger types of winds, and we would love for you to report it. And then microbursts and straight line winds. This is when you see cold air, kind of, if you see on a hot day, hot sunny day, we start seeing thunderstorms. The cold air from a thunderstorm, once it rains out, it could, and the downdraft could, the rain cooled air goes into the warm air, rushes the air that's within the thunderstorm to the ground and can result in a strong wind gust or a microburst. So microbursts, the winds flow in the same directions and cause the straight line wind damage, which is different than a tornado damage, and wind gusts could be 60 miles per hour or greater. There's two types of wet microburst when it's occurring with rain, or a dry microburst when it's just a really strong flow of downward moving winds. So this is a video of a wet microburst. So you can really see that rain going down and then moving in all directions. And then dust storms, we can either see dust storms with generally windy days around recently plowed fields, or really strong thunderstorm outflow winds, and that's kind of when it's called from a haboob. And so we typically see dust storms in our growing seasons or in our planting seasons. So in the late spring and the middle of the spring, like March and April, and then again in like August, September, November, for planting and plowing. And these result in sudden reduction of visibility, and also cause a lot of accidents. We had a dust storm, where just a dust event last week, when it was pretty dry out and planting, and just plowing fields. We do like to see these reports as well, because we do issue dust storm warnings. And so if you can give us locations of roads and intersections or mile markers or where you're at, that is great. For heavy rain, you want to give specific locations. Again, the streets or creeks. We'll typically see impacts from heavy rain if we're seeing a half an inch in an hour from a thunderstorm. Over recently burned areas, that threshold is even lower, and like around quarter an inch to 0.3 to 0.4 in an hour. And then for more like long duration rainstorms or stratiform storms, that could be like to 1 inch in 12 hours and 1.5 inch in 24 hours. So those reports are very meaningful to us. For flooding and flash flooding, this could be rising water on rivers, streams, and low-lying areas. Again, we want to see specific locations of streams and streets, and it's important that you do not drive into flooded areas or swim in flooded areas or play in flooded areas, because the water from floodwaters is very gross and disgusting, and we do not recommend going into it. But these can cause really significant damage to homes, especially when they occur near recently burned areas, and that can result in debris flows and just significant mudslides and flooding that occurs. So that water is moving very fast. It probably, if someone drove into that, would bring their car down, lift their car and push it away, and would not be good to drive into it. So it's always remember to turn around, don't drown if you encounter any types of floodwaters. As I mentioned, mud and debris flows, very common near recently burnt areas, because the soil from a recently burned area or a fire is pretty much becomes concrete, and because the water can't penetrate into the soil anymore. And so if there's heavy rain occurring over a burn area and it's in a steep location, the water has to flow somewhere. So it'll flow down and it will bring down everything that it encounters. So if the water saturated rock is moving down a slope, it will, these are just some pictures of just debris flows. See near Bonaparte Creek Road, that was a trouble spot up between like in 2022 and 2023. And so again, we want specific locations, roadways, intersection, especially because when we do issue flash flood warnings, we really, especially when a heavy thunderstorm is occurring over a recently burned area, we don't want to waste any time. And if we see something is occurring over there, we will put out a flash flood warning. And if we see your spotter in that area, might give you a call as well. So then the last type of thunderstorm stronger thunderstorms is supercell thunderstorms. These thunderstorms aren't very common in our forecast area because we don't have as much moisture associated with it. Usually, as I mentioned, our moisture when we see our thunderstorms usually is in like upper 50s and low 60s. When you start seeing higher moisture values, especially that they see east of the Rockies, that's where supercells are a lot more common, but we do still get them here, but they're just not as common. But these are pretty long duration, very strong winds, large hail, like above 2 inches, heavy rain, flash flooding, and also tornadoes. So this is the typical structure of a supercell thunderstorm. And it's when you see that, really that, again, kind of the other classics, the rain-free base, which is where like kind of littler updraft is, but then you see a stronger updraft, and when you get that anvil reaching the top of the troposphere, and a really strong updraft, you'll see that overshooting top, which is classic sign of a pretty strong thunderstorm. And then you'll have just other aspects of the thunderstorm, such another downdraft, which you'll see a rear flank downdraft when there is pretty strong winds. And then you could also see a tornado as well, but we typically don't see tornadoes, but if we do, they might be occurring with the supercell. But then when we see a really strong or a really big hail, when we see like the hail that I mentioned earlier, that storm that went through Liberty Lake and Otis Orchard was associated with the supercell. That's when we really get those big hail sizes. So some pictures that occurred showing some real views of some supercell thunderstorm features is that overshooting top, the cauliflower-shaped towers, also that mesocyclone or wall cloud. So some other, the anvil doesn't represent the direction that it's moving, because you can see in this image, it's not really clear what the direction of this thunderstorm is moving, because the anvil, it's the updraft moving the air above and making the cloud grow tall, but then once it reaches the top of the troposphere, temperatures start increasing with height. So kind of like when you start seeing more stable atmosphere, once you get into the stratosphere, it's a lot more stable of an environment, and so the air starts warming above it, and then the cloud can't go any higher generally, so it'll spread out in both directions. But if you have a really strong supercell, it will actually, or strong updraft, it will overpower that it will overpower the warming temperatures and will shoot above into the tropopause and the bottom of the stratosphere. And then some other cloud types we typically see on our fair weather days. It's just warm and there's some moisture available, and you might see some of those single cell thunderstorms. Yeah, Heather asked, does the overshooting top only typically occur in supercells? Yes, because you really need that strong, pretty strong updraft with it. So you really need that strong updraft that usually occurs with supercells. It doesn't have, it's typically with supercells, but they can occur in other cumulonimbus clouds if there is a lot of instability. So they could happen with multicells as well. But it is a classic sign. It is a classic feature of a supercell. But you could also see the cumulus clouds. Yeah, that's when we see our single cell or just our fair weather cumulus days. The Mattis clouds, they happen with more unstable atmospheres. The towering cumulus, again, we could see those with, that's kind of an indication that there is a lot of instability in the atmosphere, and they can occur with fires as well, but they're called pyrocumulus, where like really unstable atmosphere around a fire can actually create its own clouds and weather. And then a wall cloud, they occur with stronger thunderstorms or supercells that are indication with some rotation. And then in the winter time, this is when we start in our really overcast days, is when we see our stratus clouds and are typically more stable, and they hug the mountain. And you might see when you're going skiing or snowboarding and you're at the top of the mountain and you see just a pool of clouds or ocean of clouds. Those are typically stratus clouds. And then scud clouds, which are more raggedy clouds that sometimes can be falsely identified as a funnel cloud or tornado, but they're not actually tornado or anything. It's just like the bottom of a cloud. Oops. So a tornado, if you think you see a tornado, look at the ground, look at the cloud base. Is it connected to the cloud base? Is it connected to the ground? If so, then yes, it is a tornado. If it's not one or the other, if it's connected to the cloud base but not the ground, it's probably a funnel cloud or identified as a scud cloud. Or if it's not connected to, it's connected to the ground but not connected to the cloud base, it could be a dust devil. But actually, dust devils usually happen when it's pretty sunny out, so you might not even have any clouds. Our typical inland northwest tornado are usually on the ground for less than 5 minutes, which is hard to see on radar because our radar scans come in every 5 minutes. So if a tornado occurs between the radar scan, we're not going to see it. They're very short-lived, don't travel very far, about a quarter mile track or 100 yards in diameter. We're mostly EF0s to EF1s with max wind speeds up to 85 to 150 miles per hour. And here are some pictures of inland northwest tornadoes that have occurred over the years. Here's video. You can see it's not actually as visible in the middle but you can see kind of the rotation at the top and the rotation at the bottom. It's kind of cool. I don't know any specifics about this tornado because if you look at the previous picture, I don't think any might have happened in 2016. And here's another video. This is from 2022.
Yeah, that's a tornado. It's starting to form right here.
There's very minor damage with those, at least with the second video. I think it was an EF0. But how are tornadoes measured? They are measured on the EF rating scale. And so the EF scale is a damage rating scale. So you can't actually know what an EF scale is, what EF a tornado is by looking at the tornado itself. It is measured by how much damage was observed. So the EF stands for Enhanced Fujita Scale, which is the scientist who developed it. And yeah, so most of our typical tornadoes are EF0 to EF1. EF0 is more common with minor damage, such as shingles blown off, or branches broken, some trees uprooted, or some overturned vehicles. So we typically see those EF0s, EF1s. And as I mentioned, May is our tornado season in the inland Northwest. Typically these occur in the afternoon, and most of them have also been an EF0. This is a look, like kind of a map of where inland Northwest tornadoes have occurred between 1950 and 2017. And to see they can occur across pretty much anywhere in the inland Northwest. They can occur, but it's very uncommon. So non-supercell tornadoes, they can also be called land spouts, and these are narrow rope-like condensation funnels that they do reach the ground, and they can form during the towering cumulus or a mature stage of a thunderstorm. And this is different than a tornado because there's no rotating updraft within the storm. So the spinning originates near the ground, whether as like a boundary move through, like an outflow boundary from a decaying storm, or just a stronger wind from precipitation occurring, and they collide, and the spinning originates near the ground, and then it kind of moves towards the cloud. And then what about funnel clouds and dust devils? Funnel clouds stay aloft, attached to the storm, and they don't actually touch the ground. And they can occur generally when we're seeing like cooler, we also call them cold air funnels. And they don't cause any damage because they don't touch the ground. Dust devils are typically formed on very hot days in farm fields, and they could be pretty windy when if you see it cross the road. And they're really cool, but they typically occur when there's no clouds in the sky. We do like seeing these reports, so if you do want to share with us, we'd be glad to receive those pictures. Also, yeah, I see them all the time if you're driving from like here to Seattle too. They're cool. I really like seeing them as well. Also, cool air funnels, as I mentioned, these don't touch the ground either, and they typically occur when we're in a cool and an unstable atmosphere. So here's another poll question. Oops, this is kind of harder because you can't really see the image with it. So I won't let this go for too long because I didn't really give you that much to see it. But everyone's doing pretty well. This was a wall cloud or mesocyclone. Oops, I got rid of that one. So some basic radar interpretation. So radar is, we have a radar at our office, and it is a spinning antenna that measures different slices of the atmosphere. It starts at a 1/2 degree angle, and then it could go up all the way to about 19 degrees, 19 degrees of an angle. And it takes about 5 minutes for a full radar scan to occur. And it measures near the beam, it measures base of the convention near the ground up to the tops of the cloud. Near the radar, it sees pretty low in thunderstorms, but then once you get further out from the radar, especially into like central Washington or southeast Washington, or the southern Idaho panhandle, the 1/2 degree slice of the radar would actually be measuring the middle of the storm. So the main product that we use for radar is reflectivity. So it sends out a signal, and once it hits an object or like a raindrop, it measures just how intense or how large it is. So it usually measures precipitation, but not always how much precipitation is falling and how big it is. So the base tilt of a radar is that 1/2 degree slice, which is just one slice. So if we say tilt at any degree, that is 19, one slice of the radar. But if we say a radar composite, that combines all of the slices that it measured and displays the highest one out of all of the slices. So another product that we use for radar is the velocity, and this measures the speed and directions of the targets, either the rain, snow, hail, or debris, or even the biological particles, especially if we're seeing a strong wind gust. So on a radar, if you're seeing the red, that is a target that's moving away from the radar, or green, that's moving towards the radar. Base velocity is good for measuring ground relative motion for the storm. So it's good for measuring this, like the speed of straight line winds. And then storm relative velocity is, it removes how fast the storms are moving. And it's good for measuring like how the rotation of the storm. I like that one because I had trouble. It's one of the things that I had trouble remembering, like which one was red, which way was red, and which way was green. Heather said that she likes to think of the radar as wanting friends. So red is moving away and green is moving towards. I think of it as red light, green light. Like when you're playing the game, red light, green light. If the person who's facilitating says green light, you run towards them, and then red light is just the opposite. You just stop, say nothing, do nothing. So some other radar products that you could use and that we utilize in our severe weather operations is correlation coefficient. And this provides a measure of the consistency of the shapes and sizes of the target within a beam. So the higher value means there's higher consistency in the size and shape of the radar targets. So it could go up the normal values 1, where you see like just rain, just normal rain or snow, and the shapes are all generally the same size. But so the higher value, higher value is higher consistency in the size and shape of the radar targets, and the lower value is there's greater variability in the shapes and sizes. So we use this to distinguish between meteorological and non-meteorological targets. So if there's pretty low correlation coefficient, that can be used to identify tornadic debris, to identify giant hail, and also check the quality of other products as well. Then you can also see bugs and birds and buildings on the correlation coefficient as well. And for other radar products, we have the hydrometeor, or just rain, or type of precipitation classification. There's a differential reflectivity, which helps identify the target shape. So more spherical, such as hail, debris, or snow, or near zero. The second image is what that looks like. A more horizontal target, elongated targets, or it could be like medium to large range-offs, typically positive values. There's the specific differential phase, or KDP, and this helps identify regions of heavy rain, or higher KDP values, indication of pretty heavy rain rates. But you can also use these products in combination, where a region of very low correlation coefficient, typically less than 0.97, and low KDP, which is generally less than 1, within a strong thunderstorm could mean large hail, such as like 2 inches or above, is occurring. Many weather products use universal time, which is what's also called Greenwich Mean Time, or Z time. And right now we are in daylight time. So to get our time, to get UTC, you would add 7 hours to our current time. So if it's 10 a.m., the time in Greenwich Mean Time would be 17 UTC. And we generally launch our balloons for 0 and 12 common times for models, and that's typically the time we are launching our balloons. We're running out of time, so I'm going to skip these poll questions, skip the last poll question. But some spotter safety, you are the most important. Your safety is more important than getting a weather report. We want you to stay safe and to drive all attention. If you want to measure something, to pull over and just prioritize your safety. We don't want you to get hurt or your family to get hurt, and so we really just want you to remember that. Especially for thunderstorms, when you are in lightning, thunderstorms can strike as far as 10 miles away from the storm. It's important to stay inside a vehicle or in a indoor shelter if thunder is occurring. Some cute things to remember is when thunder wars, go indoors, or if you see a flash, dash inside. For large hail, the larger that hailstone gets, the faster it falls. So golf ball sized hail is falling out of a cloud at 66 miles per hour. So that's really going to hurt if it hits you in the head. Or just, it's important to stay inside. See, even like once you get to really large sized hail, even golf ball, baseball, even being inside a car is not safe. So it's important to be inside. Flooding, again, as mentioned, driving, to prioritize your safety. Do not drive really fast in a thunderstorm to find reports. Hydroplaning is a serious threat and has resulted in fatalities of storm chasers out in the central US. And so it's really recommended to drive with speed limit or below, drive through the conditions that you are in. Q1, as I mentioned, is turn around, don't drown. And if you're a tornado, outside is not safe in a tornado. It's important to be in a structure or be in the lowest level of a sturdy building. If you don't have a basement, be in a small interior room away from windows. While tornadoes don't occur frequently in the Northwest, they can occur. And if you are traveling outside of the Northwest, the central US, where tornadoes are more common. These are definitely important tips to remember. And also be careful at night. It's important to make sure that you are just using common sense when looking for storm reports. So for resources, we do have a spotter resource page. It's weather.gov/OTX spotter_resource_page, and that has resources for weather information, but also for our spotter training schedule and for recordings of past year's spotter training, and also more resources if you want to learn more, such as self-guided training over the Comet Met-Ed or some sky warning training, COPA-ROS training, if you want to keep learning on your own. So quickly go into our seasonal outlook. Since the start of the calendar year, our precipitation has been around normal to slightly below normal, and temperatures have also been normal to slightly below normal. Our current water supply outlook is we're in our spring melt off season. So we're going to start seeing the mountain snowpack melting off and seeing higher flows on our rivers, but we are seeing our current snow water equivalent about 70% of normal, and so most of our flooding that could have occurred is past, so our higher flows are generally past, and we'll start seeing the downtrend of them. The Cascades is in a moderate drought, along with most of Shoshone County is a moderate drought. We did see a good amount of precipitation this winter that has kept generally most of eastern Washington drought free. And then for the drought outlook, the Climate Prediction Center is projecting that the drought will persist through the summer. For our seasonal wildfire outlook, given the melt off of the mountains and the drier conditions expected for the summer, the seasonal outlook potential for July is projecting an above normal wildfire outlook, with the spring kind of equal chances for above or below average temperatures, and same with precipitation. And then for the summer, kind of projecting that below normal precipitation and above average temperatures. And that's all I have. So what's next? You will receive an email from our NWS Spokane account or from Robin Fox with a form to register as a weather spotter, and you will get your spotter ID and your spotter training certificate after that. If you do want to email us in the meantime, you can reach us at nws.spokane@noaa.gov. Thank you for listening to me talk for the last hour and a half, and I will unmute you if you want to ask any questions. I'll stick on for the next couple minutes. Thanks, Nick, for submitting your registration. Once we are done with all of the trainings, then Robin will go through and give everyone their numbers and certificates. So there's one more training, I think next week, and then after that you should receive your information.